Hello, this is Mr. Agbamu Idanogwenen. In this class, I'm going to show you how you can find the gradient of a curve using differentiation, that is the y dx. You remember in our previous class on gradient, I showed you how you can get the gradient of a curve or gradient of a straight line when 2 points are given. But this time around, you want to get the gradient of a curve. All you just need to do is to differentiate, then get the point at which you are getting the gradient, substitute the value of x in the dy dx value. So that is all. So these are one of the applications of differentiation. Why we say calculus, which is differentiation, is very important in mathematics. Normally, if you want to get the gradient of this curve that we have here, this example we have here, you need to plot the graph first. After plotting the graph, then you trace the point where x is equals to 1, draw a tangent through that point, then find the gradient. But before you take your time plotting the graph, drawing the tangent, getting the gradient, you can see that time has really gone. Why not just use your dy dx and get your result? So to start now, all we need to do is to differentiate this function of y, which is y is equals to, so let's turn it to index form first. This is 2 root x, so I'm going to have 2x raised to power 1 over 2. So you need to turn it to index form first, minus, so now be minus 1. Okay, let's turn this also to index form, 1 over x, now become x raised to power minus 1. So it's better you put it in index form so that you can easily differentiate it. That is why we are putting it in this form. So when we are through with that, the next thing we need to do now, let's differentiate now. So we said dy dx will now be equals to, so you follow your rule for differentiation. So when we apply the rule, the power is going to multiply the coefficient, which is half times 2 is going to be 1. Then you subtract 1 from the power, so this is going to give us x raised to power minus 1 over 2. The power is half, so half minus 1 is minus half, so you are through with that. Then the next one is this term here, minus 1 times minus 1 is going to have plus x. Then minus 1 is going to give us raised to power minus 2. So that is the differentiation of this. So let me put it in this normal form now. Then we have dy dx. So dy dx will now be equals to 1 divided by x raised to power half, x raised to power half, plus 1 over x raised to power 2. So that is this side. So finally, let me arrange it in the order that we can understand it better. So let me remove this half, turn it to square roots. So we have dy dx. So dy dx will now be equals to 1 over square root x plus 1 all over x square. So that is that. So now that we have differentiated this function, so this is our result. The next thing is now substitute your value for x. We say at point x is equals to 1. That is all. Then you just substitute it there, and that is the end of the question. So dy dx at x is equals to minus, at x equals to 1 will now be 1 divided by square root 1 plus 1 divided by 1 square. So finally this is going to give us, so if you solve this very well, you are going to have 1 square root of 1 is 1, 1 over 1 is 1 plus 1 square is 1, 1 over 1 is 1, which is 1 plus 1. So the answer is going to give us 2. So that is all with this. So that means the gradient of this function at point x is equals to 1 is 2. So that is the answer of this question. You can see that it's very easy to get the gradient of any curve when you know the point at a particular point at that curve. It's easy to get the gradient instead of plotting the graph and taking your time. So even if you are asked to plot the graph of this function and get the gradient at the point x is equals to 1, you can actually check your answer using this method before plotting the graph, especially in theory questions. When you are writing exam like YX, you may be asked to plot a graph, find the gradient of the graph. So you can actually use this dy dx to get the gradient. Then from there you can now check. When you are plotting the graph, you can easily check to avoid mistakes. So that is that. So let me demonstrate this. Let's plot this graph. Let's see if this answer is correct that we got here. So if I plot this graph here, which is 2 root x, if I plot it there, which is y equals to 2 square root, let me get my square root here, to 2 square roots, let's put our value, 2 square root x, then what next? Let me see the question. Say 2 root x minus 1 over x, so minus 1 divided by x. So that is that. So you can see how the graph goes. So you can see the curve now. So this is the curve. So after you have plotted this graph, then they now say get the gradient at point x equals to 1. Let me just get any point on this curve. Let's put the point somewhere here. So let's get our tangent. Okay, this is my tangent on this line. Okay, because you need to draw your tangent to the curve before you can get the gradient. So let's get the gradient, which is the slope. So gradient of this tangent now. So at this point, gradient is 0.44. So let's see, what did the question say? The question says find the gradient of this curve at the point x equals to 1. So I need to move this point to x equals to 1. You can see x is 5.98 at this point. You see, almost close to 6. So let's move it to x equals to 1. So just be checking. When x is 1 here, you will see that this gradient is going to be 2. So you see x is getting close. This is 1 is somewhere here. You see that when x is 1 here, the gradient is going to be 2. So this gradient is going to be 2. That's what we are talking about. You can see it's getting close to 1. Gradient is going to be 2. So that is it. So which is this point. So you can see it when x is 1, gradient is 2. So that is all with the question. There's nothing so difficult about it. It's a very simple question. That is all about gradient. It can never be difficult than this. Questions can come in other forms. They can make it, they can give you the gradient. Maybe gradient is 2. They will tell you to find the value of x. The function is given. It's the same approach. All you need to do, you differentiate first, put your answer for the gradient, then you solve. You know, mathematics, we do so many tricks just to make sure you understand the topics very well. For example, let me put this question I have here. Okay, let me put this. Let's just call it example 2. Let me come down. Let's call it example 2. Okay. So you can be asked to find something like this. Let's see example 2. So find the point x comma y. So this is what I'm talking about. They can tell you to find this point. So they can ask you to find the point x and y, just like this one we did. You can see the point is 1. When x is 1, y is 1. Then the gradient is 2. So just like that. So they can tell you to find this point. They will give you so they say find the point on the Euclidean plane now. On the Euclidean plane to the point where the curve, so this is the curve now, y is equals to 2x squared minus 2x plus 3 has gradient 2. So it has gradient equals to 2. So question can come in this form. So I just want you to take note. So it's the same thing you are going to do. So when they tell you to find the point, this is the point on the Euclidean plane where the curve, so this is the curve, has gradient 2. So find the point where the gradient is 2 on this curve. So all they just want you to do, differentiate this function, and when you are differentiating it, you have your dy dx. So dy dx is going to be equals to, just differentiate it, which is 2 times 2, which is 4x. You're having 4x minus 2. You have 4x minus 2. Then since they gave you the gradient as 2, you just say 2 is equals to 4x minus 2. Then if you solve very well without wasting time, x is going to give us what now? S is going to be equals to 1. So that is it. So x is going to be 1. So when x is 1, how do you get your value for y? So to get your value for y, you substitute here. When x is 1, y is going to be what? So you just say y is equals to, substitute 1 in this place, which is 2. You have 2, open bracket, 1. Okay, let me adjust this. Okay. So 1 raised to power 2, then 2, then minus 2, minus 2x, and plus 3. So that is it. Yeah. So when you now solve for your y, now y will now be equals to what now? Y is going to be equals to, so this is 1 square 1, 2, 2, then this is also 1, so 2 minus 2 is 0, so y is equals to 3. So that is that. So there's no stress with this one. So this is your value. Then the value for the x and y that they ask you to find now, without wasting time, you just get just say the point. So the point xy will be equals to what now? So the point x comma y will now be equals to, so you have gotten your answer now. So x is 1, then y is 3. So that is that. So this is the answer. So there's no stress with this. So you take note of that. So if the question comes in this form, you do the same thing, differentiate, then get your value for x. The gradient is 2. So dy dx is gradient, substitute and solve for x. Then x, put the value of x as 1 in the main function, and you get your value for y. So that is that about gradient. Let me just demonstrate this using the graph so that you understand it very well. So if you plot this graph, you will discover that when you plot this graph at this point, when x is 1, y is 3, you are going to get gradient 2. So that's how you know if your answer is correct. And let me put it so that we get what we're talking about. Let me delete this that we have done before. So if I have my y equals to 2x squared minus 2x then plus 3, I'm going to get this. So that is it. This is the function. So we said gradient is 2, but before we do that, let's get a point and let the point be 1 and 3. So if I get a point there, if I get a point on this graph and get a tangent to that point, which is this. So let's get the gradient. So you will see that when this point, when x eta is 1, you can see it. See, when x is 1, y is 3. When x is 1, y is 3. You can see that the gradient is 2. So that's what we are talking about. So this is a good question for practice. You can see it. When x is 1, y is 3, then the gradient is 2. So without plotting this graph, you can actually solve it. You see, when x is 1, y is 3. You can see the result when the gradient is 2. So this is all I want you to get in this short video I have for you. So go through the video, go through the previous example. You can see it very simple and okay. Then from there you can study these few questions I have for you here, and that is all this class. So we'll meet another time for another interesting video. Have a nice day.